In the modern era, aircraft carriers are not only a symbol of a nation's military might, but also a symbol of technological progress in the maritime industry. In recent decades, Turkey has developed into one of the most advanced maritime defense industries, thanks to its shipbuilding and defense technology companies. In Turkey's Modern Design Center, hundreds of large monitors display digital blueprints of aircraft carriers in holographic and three-dimensional animation. Design teams typically include experts in aerodynamics, mechanical engineering, electrical engineering, and radar systems. They work simultaneously on a super-fast computer network that allows design changes to be made in real time. Giant steel sheets are delivered to the shipyard using heavy-duty vehicles and high-capacity cranes. In the fabrication area, automated laser and plasma cutting machines begin to cut the steel to computer-defined shapes. The cutting precision can be as low as millimeters. After being cut, the steel sections are shaped using giant rolling machines to create the curve of the ship's hull. This process requires enormous hydraulic pressure, as the thickness of aircraft carrier steel can reach tens of millimeters. Each steel panel is then digitally coded for easy tracking within the automated production system. Turkey employs a modular construction concept in the construction of modern aircraft carriers. This means the ships are not assembled as one large unit from the start, but are instead divided into dozens to hundreds of separate modules. Each module represents a major section of the ship, such as an engine room, aircraft hangar, control room, or flight deck. Modern welding robots use laser sensors to ensure precise steel joints. This technology is crucial because even small errors in joints can affect the overall structural strength of the ship. After welding is complete, each joint is inspected using ultrasonic scanners and industrial X-rays to detect microscopic cracks. One of the most complex areas of aircraft carrier construction is the installation of electrical and electronic systems. Modern aircraft carriers have thousands of kilometers of cables connecting radars, communications systems, combat sensors, data centers, and even fighter aircraft control systems. Technicians must install cables in special, computer-designed paths to protect them from engine heat and the risk of electromagnetic interference. Wiring errors can cause combat system failure, so this stage is carried out with extremely stringent safety standards. In addition to the electronic systems, the installation of the main engines is also a major challenge. The aircraft carrier's turbine engines are enormous, producing hundreds of thousands of horsepower. They are lifted using giant cranes and precisely installed into the main engine foundations within the ship's hull. On the flight deck, engineers install a special heat-resistant steel layer, capable of withstanding the extreme temperatures of fighter jet engine blast. The deck surface is also designed to have high grip so that aircraft can take off and land safely even in rough seas. The ship's radar and air defense systems are installed in the final stages. Modern aircraft carrier radars use phased array technology capable of detecting air and sea targets hundreds of kilometers away. All radar data is transmitted to the ship's command center via a high-speed military computer network. At the Turkish shipyard, the final assembly process is a spectacular sight. Giant modules weighing thousands of tons are lifted using gantry cranes as tall as multi-story buildings. The modules are then precisely joined together to form the complete aircraft carrier structure. Once the main structure is complete, the ship undergoes the outfitting phase, or the refinement of the interior and operational systems. During this phase, crew quarters, a medical center, an industrial galley, an air conditioning system, ammunition storage, and a flight control center are installed. Modern aircraft carriers can carry thousands of crew members and dozens of fighter aircraft, making their facilities resemble small floating cities. They include their own electricity generation system, seawater treatment into fresh water, and an automatic firefighting system throughout the ship. The next stage is sea trials. The completed ship is taken to the open sea to test its engine performance, stability, radar, communications, and weapon systems. During these tests, the ship undergoes various extreme maneuvers, including full-speed runs and simulated combat conditions. Engineers monitor thousands of digital sensors during the trials. If any technical issues are found, the ship will return to the shipyard for repairs before being officially handed over to the Navy. Turkey's success in building modern warships demonstrates a major transformation in the country's defense industry. Significant investments in digital design, technology, industrial robotics, and precision manufacturing enable Turkey to compete with the world's largest shipbuilding nations. The aircraft carrier industry also has a significant economic impact. Thousands of workers are involved, including engineers, metallurgists, CNC machine operators, electronics technicians, and logistics workers. Furthermore, the construction of a single aircraft carrier can mobilize hundreds of domestic component supplier companies.